All right, so in this, we are going to be looking at area of a sector, and this is going to be relating the area of a whole entire circle. So this whole circle here, for example, to this sector we have, which is here. So we'll start again with area of a sector, and area of a sector starts with the area of a circle. Area of a circle is pi r squared, and we're going to be multiplying it by the ratio of our theta divided by our whole circle, so 360 degrees. That would be the shaded area, the green shaded area here. This can also be written in radians, so that would be pi r squared, and now instead of being multiplied by theta over 360, it'll be theta over 2 pi, because 2 pi is a circle in radians. We can also simplify these. Now, we can't simplify in degrees because something will cancel out, so that actually will stay as it is. But in area of a sector for radians, my pi's will cancel out, so I'll just be left with r squared times theta divided by 2, which when solving can be more easily seen as 1/2 times r squared times theta. Just like with arc length, I'd recommend starting with our original formulas and then simplifying after, because those are a lot easier to remember in their base forms. So let's go ahead and apply this in the question below. So finding the area of the sector, I have a radius of 8 and a theta of 30 degrees. So I'm going to be using my degree formula since my original angle was given to me in degrees. So that's going to be pi times r squared, 8 squared, times theta, which is 30, divided by 360. I'm going to start simplifying things down. Pi times 8 squared is 64, and then 3 divided by 360, that can simplify down to 1/12, because 360 or 30 divided by 360 or 30 divided by 30 is 30, 360 divided by 30 is 12. Now I can also simplify 64 times 1/12. So I'll illustrate this as first pi times 64 over 12. If I go ahead and divide 64 by 4, I will get 16. So I'll have 16, and 12 divided by 4 is 3. So I'll have 16 pi over 3. And so that would be the area of my sector, 16 pi over 3. Your unit would be meters squared. Now I can also do this in radians. So let's first just convert my degrees to radians. I'll do this in blue. So I will have 30 times pi over 180, which that would give me pi over 6. So when I go ahead and plug this in, I'll have pi times 8 squared, 1/2, and my theta, which is pi over 6. I'm going to get rid of my pi here, actually, because my pi's canceled out. So I'll just have 1/2. Let me actually just rewrite this whole thing because I kind of messed up a little bit there. I will have 1/2 pi, nope, 1/2 r squared theta. So when I go ahead and plug everything in, that's equal to 1/2 r squared, 8 squared, times theta, which is pi over 6, which is equal to 1/2 times 64 times pi over 6. 1/2 times 1/6 would give me 64 pi over 12, which, as we simplified earlier, would give me 16 pi over 3 meters squared. So again, just like arc length, area of a sector will give you the same way, whether give you the same solution, whether your theta is in degrees or radians to begin with.